Students, so today we'll solve the numerical problems from the chapter motion in a straight line. As we have completed this chapter motion in a straight line, we'll solve the numerical problems. So let's go to the first problem, that is a car moving along a straight road with a speed of 126 km per hour is brought to rest within a distance of 200 meters. What is its retardation, and calculate time taken for the car to stop. Okay, so before going to solve this problem, we'll see what are the given things in this problem. Okay, write down given. Okay, so see here, a car moving along a straight road with a speed of 126 kilometer. They have given the speed, that is velocity, 126 kilometer per hour. Okay, that is an initial velocity because it started moving. Okay, a car is moving along a straight road, it started moving. Okay, u is equal to 126 kilometer per hour. Okay, next is brought to rest within a distance of 200 meters. So what they have given, the distance, we'll write the distance as s is equal to 200 meter. Okay, so see here, this initial velocity is given in kilometer per hour and the distance is given in the meter. So we'll convert this kilometer per hour into meter per seconds. How to convert? So kilometer into meter is 126 into 1000. Okay, divided by what? Hour. So how many seconds? 3600. So what happens? 35 meter per second. Okay, we have converted this u is equal to 35 meter per second. So next is, what is its retardation? Now we'll calculate. What is this retardation? This retardation is nothing but the negative acceleration. Okay, only the negative sign we have to give. We have to calculate the acceleration. This is the acceleration with the negative sign. Okay, this retardation is the negative acceleration. Don't get confused, this is a new word. This is the acceleration. And what they have given, and calculate time taken for the car to stop. Okay, time we have to calculate, and we have to calculate the acceleration. Okay, we'll take the equation v square is equal to u square plus 2as. Okay, this is the equation of motion which we have derived. We'll take this to solve this problem. We'll rewrite this equation. A is equal to, because we need the negative acceleration, that is retardation, we'll take A this side, LHS side. A is equal to v square minus u square by 2s. Got clear? We have rearranged this equation. So next we'll substitute this u value and s value in this equation. V is 0 because they have not given the final velocity. 0 minus 35, that is u square, divided by 2 into, what is the distance? 2 meter. Okay, so what is 35 square? 1225, and this is 400. Finally the acceleration, that is retardation with the negative sign, 3.06 meter per second square. So this is the retardation. Okay, next we'll take another equation, that is v is equal to u plus 80. This is also equation of motion we have derived in this chapter. So v is 0 as you know it, and next one we have to calculate is time. T is equal to, taking this side, minus U by A. So what is minus U? Minus 35 divided by A is minus 3.06. So minus minus get cancels. So T is equal to 11.44 seconds. So this is the time taken. So we calculated the retardation, that is negative acceleration, by using this formula, and later for time we used this formula and we calculated 11.44. Hope this is cleared. So let's go to the next problem, that is a car moving at 80 kilometers per hour is subjected to a uniform retardation and brought to rest in 70 seconds. Find the retardation and distance traveled by the car before it comes to rest. Here also they have asked the retardation, but here they have given the time and they have said to calculate the distance. Okay, so first what we have to do, we have to write down the given things. What are the given things? The initial velocity u, that is 80 kilometer per hour, and the final velocity v is 0, and time taken they have given us 70 seconds. It is brought in rest with 70 seconds. So we have to convert this also in meter per seconds, that is 80 into 1000 by 3600. What we get it as 2.22 meter per second. Okay, we know u, we know t, so we have to calculate the retardation, that is acceleration. Find the acceleration they have given. So we use the formula v is equal to u plus at. So what is v? That is 0. U is 80, but we have taken it as 22.22. So we'll write it again. 0 is equal to 22.22 plus a into 70, that is t. So we'll take this side, u is equal to minus 22.22 divided by 70. So what we get it as minus 0.3142. Okay, so retardation with a negative sign, we write the retardation as 0.3174. Next, they have asked the distance traveled by the car before it comes to rest. S is equal to ut plus half 80 square. As you already know this equation and you have derived this equation too. So we'll substitute u, a value, t value and u value. So we'll substitute the u value, that is 22.22 into t is 70 plus half in the bracket of what is a, minus 0.3174 and t square. T square is 70 square is 4900. So using calculator, simple calculator, calculate this and finally we get 77 7.8 meters. So this is the distance and this is the acceleration, that is retardation. So these are the two things they said us to calculate in this problem. Hope this problem is clear for you. Let's go to the next problem. Let's read it out. A body moving with the initial velocity 83 meter per second moved under constant acceleration of 3 meter per second square. Find its velocity after 2-second time, after which it will stop, and the distance it will travel before coming to rest. Okay, so what are the given things in this formula? A body moving with the initial velocity, that is u is given, u is 83 meter per second, moved under the constant acceleration, a is given 3 meter per second square. Okay, and find its velocity after t second time. What is given? T is given 2 seconds. So what they have said, find its velocity, that is final velocity we have to calculate, and next after which it will stop and the distance it will travel before coming to rest. They have asked the distance also, that is yes also we have to calculate. So first we'll calculate the v. Okay, v, what is v is equal to u plus at. This is the equation of motion. So substituting the values, what is u? 83 plus a is 3 into 2. So 83 plus 2 3s are 6. So what happens? Final velocity, that is velocity after 2 seconds is 89 meter per second. So we find out the velocity, that is final velocity. Next we'll find the distance. We know the formula, s is equal to ut plus half at square. Okay, what is u here? Again we'll substitute all. 83, t is 2 plus half as it is. What is a? A is 3 and t is 2, that is 2 square. Now 83 into 2 is 166 plus half 4, 2 square 4, that is 4 into 3 is 12. So 6 are, so 166 plus 6 will be 172 meters. That is the distance. So we have found out the velocity, final velocity and the distance.